Foundations of Amateur Radio. When you start in this hobby, one of the most frustrating aspects is that of selecting the right antenna. If you've been around for a while, you'll discover that this continues to be the case, even when you've been licensed longer than I've been alive. In the past, I've discussed at length why that is the case, but to recap, consider a dipole antenna. In essence, it's two pieces of wire that are connected to the radio via some form of feed line. Now consider the idea of changing the length of each wire. You could trim each end in the same way, or you could make one end longer than the other. You could fold the ends at an angle, or you could mount the dipole near the ground, or high up in the trees. You could position it vertically, or arrange the wires at an angle towards each other. You could make the wire thicker or thinner, from different material, or arrange the ends so they meet up in a circle, or a square, a triangle, or some other shape. You get the point. There is endless variation arranging this single antenna, and I've not even discussed things like feed lines, traps, chokes, counterpoise, and other RF shenanigans. With that in mind, amateurs around the world are attempting to improve their antenna system every time they get on air to make noise. Recently, I reported that my 10 milliwatt whisper or weak signal propagation reporter beacon was heard 13,455 kilometers away in Sweden by Mats Sierra Mike 3 Lima November Mike on the 10 meter band. The signal report was minus 25 dB, which means that with an experimental cutoff for a successful decode at minus 34 dB, I have 9 dB to play with, so at least theoretically, I could reduce my power even further to 1 dBm, or just over 1 milliwatt, and still make the distance. The antenna I'm using is one built by Walter, Victor Kilo 6 Bravo Charlie Papa, now silent key. It's a 40-meter vertical antenna helically wound on a fiberglass blank and clamped to the side of a metal pergola. The antenna is tuned to the 10-meter band using an SGC SG237 antenna coupler, essentially a device that can add or remove inductance or capacitance to make my antenna appear resonant on the appropriate frequency. The antenna coupler, in turn, is attached to about 20 or 30 meters of 75 ohm quad shield RG6, which I have left over from my remote internet satellite dish installation days. That's all to say that the antenna system for my beacon is suboptimal, and it's likely that my actual power output is lower than the 10 milliwatt that my beacon is reporting. So, with all that in mind, what else could I try? I have an indoor telescopic antenna stuck to the window, and I've been wondering if I can attach my beacon to it directly and leave it running without the need to worry about disconnecting the beacon when I'm wanting to fire up my actual station to make other noises on air. A quick scan with the analyzer reveals that the lowest frequency out of the box is about 60 megahertz. I decided that adding some loading coils might help, so I set about fabricobbling an antenna. Yes, you heard me, fabricobbling. Fabricating and cobbling together. Anyway, using 7mm thick drip irrigation riser polypipe as a form, I wound 2 coils with 1.25mm copper wire that I had lying around. Depending on which calculator you used, that was either too much or not enough for my needs. I managed 53 windings, shy of the planned 60, but still a good start. Using the same irrigation riser, which, as luck would have it, managed to match the thread for the telescopic antenna elements and feed point, I separated each element by about 100 millimeters from the feed point, then used the 2 loading coils to connect the feed point back to each element. An hour later, I now have a telescopic antenna with 2 loading coils, and as luck would have it, I'm much closer. The resonant point is now 30 megahertz, down from 60 megahertz, so I have a little more tinkering ahead of me. I might change the wire and use some eyelets at the ends to make assembly simpler, but the general idea seems to work as intended. If it doesn't work, I've come across a design for a 25.5 meter long end-fed half-wave antenna that will work on anything between 80 meters and 10 meters, and it appears that my driveway is just long enough to fit, but that will negate the indoor aspect of the antenna. All this reminds me of the ugliest dipole I ever saw, in a bush shack, a decade ago, consisting of 2 wires haphazardly soldered onto a piece of coax, looped around an insulator with a piece of wire holding it together, tied between 2 trees. It was only ever meant to be temporary, but it was there for years. I used it to speak to stations all over the Pacific, and in the process learnt a lot about the performance of both my radio and the antenna connected to it. The point being that experimentation in antenna building is what we're all about, even going backwards from multi-band high-gain antenna farms back to basics and exploration. In case you're wondering, I haven't forgotten about the Hustler 6B TV antennas packed in boxes. They're still very much part of the grand plan, but in light of my recent low-power experiments, I'm getting very curious about using antennas that really stretch the propagation friendship. Why? Because I can. What antennas have you built that you were ashamed of? I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.